chapter, yesterday already I told you, no? The change of materials. Change of materials. So there are so many materials around us. Can you tell the name of some materials or matter? It may be metal, it may be non-metal, it may be gas. Anybody, any item? Pardon? Next, yes. Then is it solid or liquid? Solid. Okay, fine. So now you see that materials, its condition can be changed. Suppose one material is liquid, it may be converted into gas. So the materials, they can change their states. Okay, and the materials, they can be changed to a new material also. So these issues today we will be discussing in your class. So the change, primarily we have two types of changes of materials and metals. That is physical change and chemical change. What are the changes?
Physical change and chemical change.
So these are the two basic types of changes of metals or materials. Now what is physical change? There are some changes when the just shape or looks of the constituent particles are not changed. This is known as physical change. Suppose you have your notebook. You take a notebook, you make it a fold, Oh. So after making the fold, what you got? You just got here like a mark, no? But the paper, it remains as a paper. Paper is not changing its actual condition or state. Just you are getting the, suppose if you do like this, you will be getting some wrinkles, right? But it is paper. After this squeezing or doing like this, paper is not changing to another state. Paper is remaining as paper only. Is it? Yes. So this type of change means, you see now, this is a plain page. This is a wrinkled page. But both are papers. Now condition, it is not looking same. Its condition, if I have a look, these are not same. It is changed. So we have this, you see, we have taken some sticks. Means this is from plants we have collected. You take. Which one? Okay. So these are the just part of a plant, right? We can bend it. Now it has been broken. But after breaking also, you see that stick of plant, it has remained as plant only. It has not changed to a new material. Am I right? Now it has been just converted into two pieces. If we try, it can be converted into more two pieces. You see now, from two pieces, we got how many pieces? But this part of plants, it has remained in the same condition. That shape, it was earlier it was long, now it has been small pieces. But the part of plant, as it was earlier, of actual constitutional particles, that is known as physical change. Now, can you give me any example of physical change? Means just the shape is changing, the state is changing, but the matter remains same. Can you give any example? Water. You please explain what are the changes you can visualize.
When we boil it, it becomes gas.
Great, fantastic. So you see, water. Water is water. when we keep water inside the fridge, means deep freeze, it becomes solid. What? Ice is water. Again, if you just bring it out, if you keep it in the normal temperature, or if you apply heat, it will be melted and again it will be water. That means ice and water, these are the same thing, just due to difference of temperature, sometimes it becomes like solid, which is ice, and sometimes it becomes as liquid, which is water. Again, if you apply more heat, the temperature goes up to 100 degree, then water will be converted into vapor, as she told. Okay, water will be converted to gas, and this gas, if you can hold, and again if you cool it, the gas will be converted to liquid, means again it will be converted to water. That means solid state of water is ice, liquid state of water means liquid water, and gaseous state of water is gas. All the things are same. There is no physical change, no change of composition, no change of its constituent particles. So these are the examples of physical change. So this is the first type of change, which is known as physical change. Now let us come substance or compound. It is changing into a new compound. New means fully new, and you cannot get it back to the original substance or compound. Change means change, and you cannot get it back. As we just now discussed about the water. Water can be converted to ice, water can be converted to actual composition or constituent particles are not changed, that is physical change. But in case of chemical change, what happens? The overall substance, it changes to new substance, means you cannot get it back. So can you give me any example of your daily life? Means what you are handling daily, that chemical change, means after changing you are not getting it back. Burning of paper. Good. So if you burn the paper, after burning we get, what we get? Yeah, carbon dioxide we get, but physically what we can see? Ashes. So paper, actually paper is a composition of carbon and hydrogen. If you burn means if you mix with oxygen. Burning means it is getting the touch of oxygen. So paper plus oxygen means burning, we get ashes. So ash, what it is actually? It is carbon dioxide and water. Water we cannot see. So this is actually, suppose paper plus burning. Burning means oxygen. We get, you see, paper plus burning means actually burning, it means that it is added with oxygen. Means it is doing reaction with oxygen. So after this reaction we are getting carbon dioxide. It is actually termed as ash. What ashes we get now? And water vapor. Water vapor we cannot see. It goes in the atmosphere. So if you want to get back again paper from these two, it is not possible. You got my point? It is not possible to get back again. So this type of change is known as chemical change. Can you give me another, means every day you see? Any more example? That fried rice or rice, what we eat now. So rice means initially we get the raw rice. Raw rice means after boiling we get boiled rice. After frying it we get fried rice. So this change also a chemical change. If you want that boiled rice, that's what we have daily. After going from here again you will have lunch. In the lunch what you take? Rice you take. In the lunch what you take? So suppose you plan that, okay, I will not eat rice today, means boiled rice today. I will keep it and I will convert it again into raw rice. Is it possible? No. Not possible. So once the raw rice, it is converted into boiled, and from that one you cannot get back the raw rice again. This is also a chemical change. So now let us see some examples here of chemical change. This is spirit lamp actually, okay? This is spirit lamp, and light it. So this is lamp. Now this is magnesium ribbon. This is called magnesium ribbon. Okay. Now this is lamp. Now can you see its color? Its color is like silver color. Not yet black, not clearly silver color also. Now you burn it. Can you see, everybody? Can you see the color?
Yes.
Okay. It is magnesium ribbon. This is an element. Its name is magnesium actually, Mg. So it is off. Now you hold it here. Here. Come back. Yes. You just see the change of its color. Okay, you come this side. Its color was like silver, like black, no? So after, okay, you keep it here. You just follow, its color will be changed. Color is changing now?
Yes.
What color you are getting? Now the color, it was like blackish, like silver color, but after getting the contact of oxygen, this light means it is oxygen, okay? Means we are burning it. So the reaction here, it happens with magnesium and oxygen. You see, now it has been white. Is it white?
Yes.
Here we have touched the oxygen, okay? Now after getting reaction with oxygen, now if you want that, now it has been white, its previous color was like blackish or like silver like this, it has reacted with oxygen, a new compound magnesium oxide is formed. A new compound magnesium oxide is formed, and the color of magnesium oxide is white. The white color what we got after burning of magnesium ribbon, that is the color of magnesium oxide. So magnesium oxide, it cannot get back again to its original compound like magnesium and oxygen. So the reaction you see, what actually happens here? It was magnesium plus oxygen. Magnesium oxide. So this is the reaction. Our main element was magnesium. We burned it. That means it got contact with oxygen. After getting contact with oxygen, we got magnesium oxide. So color of magnesium oxide is white. This is white color. So this change is chemical change. We cannot get it back again. Is it clear?
Yes.
Is it clear?
Yes.
Now let us come to another example. This is sodium hydroxide. Sodium hydroxide. Base and salt, it is a base. It is sodium hydroxide. Now I am taking little sodium hydroxide here. This is sodium hydroxide I2O, and this is known as phenolphthalein. This is actually indicator. So this is colorless, no, like water. This is also like water, means colorless. Now you see, if phenolphthalein is added with sodium hydroxide, what happens? Just you see the change of color. What color you are getting? What color you are getting? Green color. Now you see sodium hydroxide, when it got the contact of phenolphthalein, a new compound, and if you want that, no, I will change it again, I want to get back sodium hydroxide, it is not possible at all. You understood?
Yes.
So sodium hydroxide, it was colorless. Now we have added phenolphthalein with sodium hydroxide. After getting contact of both the matters, now one new substance has formed, and this change, if you want to get back, it is not possible at all. This is an example of chemical change. Understood? The color never it will come back again. Means water color, no. What we had before the reaction, we never will get it back. So this is one example of chemical change. Chemical changes together. You see, this is again. What is this?
Candle.
This is
Candle.
candle. You have every day. You have at your home. You have in your hostel. Is it?
Yes.
Candle is very well known to you. Have you followed? If you means light the candle, what happens? Have you followed? Huh? Have you thought any time that after burning of candle, means at our home, especially in the means puja mandaps, in churches, we use that candles now. When you unlight it, after a few times it disappears. So have you thought that where that candle goes? Have you thought? Huh? You tell. What is your idea about this?
After burning candle,
Yes.
the suddenly disappears.
What happens?
After suddenly disappears.
But disappearing, where it is going? If it disappears, I know. If you burn one candle, after 1 or 2 hours, you won't get anything. Some
It turns into smoke or something.
smoke. What is this smoke?
Carbon dioxide.
Okay, great. Her answer is correct. Now you see what actually happening. This is our candle. Now it is burning. I am covering it with a glass. Okay. Now can you see anything inside?
Yes.
Huh? So that smoke, no. Actually, candles where it is burned, smoke is producing, and that smoke is mixing with the atmosphere. And what that smoke is? That smoke is actually carbon dioxide and water vapor. That candle, no, it is made of carbon and hydrogen. The main constituent element of candle is carbon and hydrogen. When we burn it, it gets the contact of oxygen. So the candle, it's a compound of carbon and hydrogen. It gets contact with oxygen. They burn and produce carbon dioxide and water vapor. That smoke, what you have seen, that is carbon dioxide. It mixes with the air in the atmosphere, and we get some, you see. Now works like this. We get now. Means whole candle never disappears. Some wax we get. Now this is the example where both physical and chemical change we can observe together. This wax and this candle, they are same or different? You say me?
Same.
They are same actually. This candle and this wax, after melting we got it. When this candle melted, we got this wax. So this melted condition which we got from candle, this one and this one is same thing. So that's here the condition has changed, the shape has changed. Here it was like this, now here we got like this. But the main elements of the candle and wax are same. Here we have carbon and hydrogen, here also we have carbon and hydrogen. So this is the example of physical change, and when we covered this one of the glass, we got some smoke like things now. That smoke is carbon dioxide, and some water vapors also remain attached inside the glass. This is not visible, but this is the water vapor. So actually the reaction, this is made of carbon and hydrogen, okay? Plus oxygen, we get carbon dioxide plus water plus wax. You see, candle plus oxygen. When we burn, we get the touch of oxygen. And candle actually made of carbon and hydrogen, right? So carbon, hydrogen, oxygen, when reacts each other, it forms carbon dioxide. This is the smoke what we got. Where it goes in the atmosphere. We cannot see it. Water vapor, where it also goes in the atmosphere. We cannot see it. So for these reasons, actually the candle, its content disappears, and we get little bit wax. That is the wax. Okay. So the change of candle to wax, that is physical change, and the change from candle to carbon dioxide and water vapor, that is chemical change. If you want that all the carbon dioxides and water vapors will get, the smoke means carbon dioxide, water vapor which already mixed with the atmosphere. If you bring them back and want to get back the candle, it is not possible at all. So this change is chemical change. And candle to wax, this change is physical change. So in the same example, we got the instance of chemical as well as physical change. So these are the examples today I have explained regarding physical and chemical change of matters. Now your work will be, each and everyone, you will write 5 examples what you can see in your surrounding. 5 examples of physical change and 5 examples of chemical change. You have to note down these points in your copy and you have to show me tomorrow. Okay? Yes. This is your task. 5 examples of physical change and 5 examples of chemical change. You have to note it down in your copy and tomorrow you have to show me. Okay? Yes. So the concepts of physical and chemical change is clear? Yes. Can you explain better tomorrow? Yes. Thank you.